Question 1 asks us to add -6 plus -3. With this, if you are still struggling to add and subtract your integers, you need to do your checks or your pluses and your minuses. So the first one I have -6 plus -3. And in all, I have -9. 3 plus -4, so I have 3 pluses. And 4 negatives. Cancel, cancel, cancel. I'm left with 1 negative. So my answer is -1. Now, with that being said, these question number 2, the numbers get bigger. So I have -55 plus 37. If I start doing my minuses, I'm going to realize I have a lot more of those negatives than I do positives. So I know my answer has to be negative. Now I'm just going to say, okay, well, what's the difference between the two? Well, when I do the difference, I just take 55 minus 37 to see how many more minuses I would have than pluses if I were to write this out the long way. $15 take away 7 is 8. 4 take away 3 is 1. So my answer is -18. If I look at question 2, I have -33 plus -58. If I start doing all my minuses, I know they're all going to be negative all together because it's -33, so that's 33 minus signs, and then 58 more. My answer has to be negative. And then I just add 33 plus 58, 8, 9, 10, 11, carry my 1, 8, 9, a final answer of -91. So question number 3 and 4 are asking us to subtract. So when we're subtracting integers, if it is a smaller number minus a bigger number, you need to keep change. If it is just a bigger number minus a smaller number, for example, 5 take away 2, 5 take away 2 is just 3. Don't keep change. On these problems, we'll need to keep change because all of them have a smaller number minus a bigger number. Or minus a negative. That's when you'll want to keep change. So -7 minus 3 becomes -7 plus -3. Change. Change it to addition, and do not forget to change the sign of that second number. So when I have -7 plus -3, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 negatives. So answer is -10. I'm going to do the same thing for question 3. 5 plus -7. I keep change plus and make that one negative. 5 plus signs, 7 negative signs. Cancel. -2 left over for our final answer. So once you change it to an addition problem, it's just like those first 2 problems we did. Question 4, we're doing the same thing. -3, keep, change. -3 plus 2. 1, 2, 3 negatives, 2 positives, cancel. I'm left with -1. 4 minus -7, keep, change. Keep the 4, add, make -7, +7. 4 plus 7. Gives you 11 in all. Question number 5 says, Miguel is riding in a bike race that goes through a valley in a nearby mountain range. The table gives the altitude in feet above sea level for the 5 checkpoints in the race. Use the table to answer the questions. Question A says, the top of a hill raises 513 feet above checkpoint 5. What is the altitude on top of the hill? If checkpoint 5 is at negative 219, I need to add 513 to that because it says it rises above 513 above that. So what is the altitude of the top of the hill? Now, if you think back to just minuses and pluses, negative signs and positive signs, if I start to do this, I'm going to have a lot more positive signs than negatives, right? So I know my answer needs to be positive. Now I just need to find the difference between that. So I'm going to do 513 take away 219. Take away 9 is 4. Gotta borrow. That becomes 10. 10 take away 1 is 9. 4 take away 2 is 2. So the altitude of the top of the hill is 294 feet. Part B asks how much higher is checkpoint 4, so negative 101, than checkpoint 5, negative 219. I just need to find the difference between the two numbers. Think of a thermometer. If you have it written this way, I have 0 up here, negative 101 right here, and say negative 219 right there. I need to find the amount of degrees in between 101 and 219. Yes, I have negative degrees to set, but the only thing a negative says for temperature is that it's below freezing. I can't really go negative miles or negative degrees. The negative is just to tell us it's below freezing. So how many degrees? How many jumps does it take to get from negative 219 up to 101, negative 101? 118. Or do 219, take away 101, 9 minus 1 is 8, 1 minus 0 is 1, 2 minus 1 is 1. So the checkpoint 4 is 118 degrees higher than checkpoint 5. Question 6 and 7 ask us to evaluate the following. So we're multiplying or dividing integers. Remember, we have 2 rules for that. Same sign, the answer is positive. Opposite signs, the answer is negative. So I have negative 2 times negative 8. That's going to be a positive 16. Same side, answer is positive. Now I have 6 divided by negative 3. I know that's just 6 and 6 divided by 3 is 2, but they're opposite signs, so my answer is negative. Then I have negative 16 divided by positive 4. Those are opposite signs. My answer is going to be negative. 16 divided by 4 is 4. And then negative 9 times negative 3 is just a positive 27. Same sign, positive answer. Problem number 8 asks us to translate the phrase into an algebraic expression. So this just means going from word form to what we're used to writing it out long ways to algebraic and writing it almost in math words. So when we have the product of x and 2. Product, if I look at my chart or if I recall that, is multiplication. So I know I'm multiplying x and 2. Another thing we talked about in class, and this is super important when we're translating these, is that when we multiply a number and a variable, we write them next to each other and we put the number first. So this translated would be 2x. That is the product of x and 2. Problem 11 asks us to rewrite the following without an exponent. For your test, it is going to be without a negative exponent. So remember, when we have negative exponents, we move it to the denominator of our fraction and change it positive and put a 1 on top. If I were to then continue this and write it without an exponent, it would be 1 over 9 squared is 81. This is what I'm going to ask for the exam, writing it without a negative exponent. Problem number 10 asks us to simplify the following. So I have y to the 5th over y squared. Now, if you recall from the notes, on this one, we would subtract our exponents. So it would almost be like y to the 5th minus 2, which is y to the 3rd. However, if you forget that rule, you can write it in expanded form. So I have y times y times y times y times y over y times y. And what I can do is cancel, 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 and I'm left with 3 y's on top, which we simplify to y cubed. Question number 9 asks us to multiply negative 6v to the 5th times negative 3v. When I have them like this, the first thing I'm going to do is just multiply my numbers. Negative 6 times negative 3. Then I'll multiply my letters. V to the 5th times v. Negative 6 times negative 3 is just a positive 18. Remember, same sign, positive answer. Then, with my exponents on my variables, remember, same base, you just add the exponents. So this becomes 18v to the 6th because there's a 5 there and an imaginary 1 there. So 18v to the 6th is our final answer for 9. Question number 12 says, find each of the numbers below. Simplify your answer as much as possible. The opposite of 8 is going to be negative 8. The opposite of 0. 0 is one of those special numbers. Remember, 0 is just 0. And then the opposite of negative 2. When you have the opposite of something, it's just the number you started with. So that's negative 2. Our first opposite of negative 2 is 2, and then the opposite of that is negative 2. That's how we get back to where we started. Question number 13 asks us to evaluate the following. So what I have here is what's the absolute value of 5 and what's the absolute value of negative 9. Now, the one thing we need to remember about absolute value, so that's when we have these bars around our number, is that's asking a number's distance from 0. We talked about my trip to Kansas City and how even though I come back home, my odometer continues to stack up and add up miles, and that's because you can't drive negative miles. You can't go a negative distance. So when it's asking how far is it from 0, it has to be a positive number. So how far is 5 from 0? 5. And how far is negative 9 from 0? 9. Question number 14 says, Greg is riding up in a bike race that goes through a valley in a nearby mountain range. The table gives the altitudes, so that's the feet above sea level, for the 5 checkpoints in the race. Use the table to answer the questions. Question A says, compare the altitudes of checkpoint 2. Negative 36 compared to negative 186. When I do problems like this with the negatives, I like to think, yes, I'm in debt in both of these, but would I rather be $36 in debt or $186 in debt? 36. So negative 36 is greater than negative 186. Remember, eat the bigger number. So this would say that checkpoint 2 is higher than checkpoint 5. Part B, compare the altitudes of checkpoint 1 and checkpoint 3. I have negative 93, 1,335. Obviously, 1,335 is greater than any negative number. So my arrow, I have negative 93 is less than 1,335. So that tells me that checkpoint 1 is lower than checkpoint 3. Question 15 is going to be very similar to question 14. It says the table gives the temperatures in degrees Fahrenheit of 5 cities at 6 a.m. on the same day. Use the table to answer the questions. First one, A, compare the temperatures of city B and city C. City B is 20 degrees and city C is negative 35. Obviously, I would rather it be 20 degrees than negative 35 degrees, even though both are very, very cold. So this says at 6 a.m. city B was warmer than city C. Part B, compare the temperatures of city A and city D. Negative 14 is going to be less than negative 5. That is colder. Negative 14 is less than negative 5. So at 6 a.m., city A was colder than city D.